Write down the range of f and range of g. Okay, so we know that the graph for exponent is like this. So 3e2x is like this. And then the range will be the y greater than 0. When we have this plus 1, then the range will be plus 1, greater than 1. Okay, so the asymptote become 1. So the range of f will be greater than 1. And then for the gx, we have the y equal to x plus 1. 1 is here. So the g can be any number. Okay, g can be any real number. Okay. Next, we want to find G20, which is GG0. So G0 is what? So we know that G0 is 0 plus 1, then it's 1. So it's G1. Then it's 1 plus 1, then 2. And this will become f of G2. So f of G20, 0 is 2, f of 2. Then it's 3e2 times 2 plus 1, then it's 3e to the power 4 plus 1. Okay, so we have the 3e power 4 plus 1. Okay, then it's 164. Okay, so we can just leave it at exponent form, or you want to write as a number, then it will be 175 and 165. On the axis below, sketch the graph of y equal to fx. Y equal to fx will be this. So, and then the inverse, state the intercept with the coordinate axis and the equation of any asymptote. So this one is the asymptote. Okay. So we have 1 here as the asymptote. Okay. Then the graph of fx is like this. Okay, exponent will be like this. Okay, and then we have the y equal to x. So y equal to x is they reflected in the line y equal to x for the f and the f inverse. Okay, so f of 0. So f of 0 will be 3e0 plus 1, then it's 4. So it is 4 here. And this is 1 here. Okay, 1 is the asymptote. Okay, then we have another vertical asymptote here. Okay, then this one is 1 also. And then we have a function like this. Okay, so this is 4. So we have the 0, 4 here. Then we have the 4, 0 here. Okay, so this is the f inverse and this is the f. Okay, so if we use Desmos, so we have the 3 and then e to the power of 2x plus 1, and then we have the y equal to 1 is the asymptote, and we have the x equal to 1 is the asymptote. Then we have the y, so we have the 1 over 3 ln. Okay, and then we have the x o oh no, over should be x over 3. X over 3. This is 1 over 2. Okay, x minus 1. Okay, so this 4004 asymptote, and then we have the y equal to x is the axis of symmetry. Okay, so over here, okay, what happened here is we have the 3e2y plus 1 equal to x. So 3e2y equal to x minus 1, e2y equal to x minus 1 over 3, and then 2y is the ln x minus 1 over 3, then y will be the half ln x minus 1 over 3, that is the f inverse is the half ln x minus 1 over 3. Okay, done. The function f is defined by fx equal to ln 2x plus 1. Sketch the graph y equal to fx. So x greater than or equal to 0, we have the 2x plus 1 greater than 0, 2x greater than negative 1, so x greater than negative half. So the graph is actually like this. Okay. Uh, when x is 0, so f of 0 is ln 0 plus 1 is ln 1. Ln 1 is actually 0, so it passed to the origin. Okay, so sketch the graph of fx and the f inverse on the axis in the axis. So we have the y equal to x. Okay, this is the asymptote. Okay, then we have diffracted here. So this is the fx. Okay, wait, fx, and then the f inverse is like this. Okay, yes, correct. So we have the fx is like this, and then the f inverse will be like this. This is the f inverse of x. Okay, so we have the ln, okay, ln, and then 2x plus 1, okay, is this, and then we have the y equal to x, and we have the x equal to negative half, negative 0.5 is the asymptote, and then y equal to negative 0.5 is the asymptote, and then we have the exponent e to the power of x, and then dy by 2, and then minus 1. Okay, minus 1. So this is the graph. Okay, so here, so this is how the graph look like. Yeah. Okay, so this is the graph. Mm. So we have the ln 2y plus 1 equal to x. So 2y plus y equal to e to the power x, y equal to e to the power x minus 1 over 2 is the f inverse of x. Okay, yes. The function g is defined by gx equal to x minus 4 squared plus 1, x less than or equal to 4. So for this one, we know that the 4, 1 is the minimum point. Okay. Then x less than equal to 4, then it will become 1 to 1 already with the restricted. So we want to find the expression for the G inverse and state its domain and range. So we have the y minus 4 square plus 1 equal to x. So y minus 4 square equal to x minus 1. So y minus 4 equal to plus minus square root of x minus 1 because we take the negative side. So we take the negative only. So y equal to 4 minus square root x minus 1. Therefore, the g inverse of x is 4 minus square root x minus 1. Okay, and we want to find the domain and range. So the domain for g is the x less than or equal to 4, and the range of g is the y, the g greater than or equal to 1. Okay, so we know that domain of g equal to the range of g inverse, and then the domain of g inverse is equal to the range of g. So domain of g inverse will be the x greater than or equal to 1, and the range of g inverse will be the g inverse less than or equal to 4. Okay, and find and simplify an expression for fgx. So fgx is inside f, put in the gx, x minus 4 squared plus 1. So what is fx? So the fx is ln 2x plus 1. Okay, ln 2x plus 1. Uh, so this one will become ln 2 x minus 4 square plus 1. Okay, and then 2 this one plus 1, 2 this one plus 1. Okay, plus 1. Okay, so plus 1 and then plus 1. So 2 times this whole thing, 2 times this x squared, this whole thing, and then plus 1. Okay, so it will be ln 2 x squared minus 8x plus 16 plus 1, and then uh, no, plus 2. So we multiply with 2. Okay, plus 1. So it will be ln 2x squared minus 16x plus 32 plus 3. Then it will be ln 2x squared minus 16x plus 35. Okay, 2x squared minus 16x plus 35. Yes. So explain why the GF does not exist. So GF, so we know that for G, the x is less than or equal to 4. So the this one, okay, the fx must less than or equal to 4. Okay, but this one x greater than or equal to 0. Okay, the answer will be the function gf does not exist because range of fx includes values that are not valid in the domain of gx. So gx, okay, for gx, we know that this one, for gx, the x must less than or equal to 4. Okay, but the value of fx, the range of the fx here is ln. Ln is something like this. Ln this one just now we have find this one. Then the value is greater than 0. So in there is value that greater than 4. Okay, so the part not valid, that are not valid, is the fx greater than 4, not valid. Okay, next, find the range of f and g. So fx is 3 plus ex. So e to the power x is like this, and the range is greater than 0. And then we have the 3 plus, so plus 3, plus 3. So the y is greater than 3. Okay, so the f is greater than 3. And then the gx is 9x minus 5, something like this. Okay, the gradient is positive, so move upward. So the g is real number, can be any real number. Find the exact solution of f inverse x equal to g prime x. So g prime x is dy dx. G prime x is 9. So they want to find the f inverse of x is equal to 9. Okay, 9x minus 5 is 9. G prime x is 9. Okay, so the question didn't ask us to find the inverse function. Then we can have the x equal to f of 9. So we move the f inverse to this side. Then it will become 3 plus e to the power 9. Okay, so this will be the answer. Okay, exact solution. So this is the exact solution. Okay, and then find the solution of g2x equal to 112. So gx is this 9x minus 5. Then the g2x is ggx is g 9x minus 5. 9x minus 5 minus 5, 81x minus 45 minus 5, 81x minus 50. So 81x minus 50 equal to 112, 81x equal to 162, x equal to 2. Okay, so this is the solution. Done.